Thank you, everyone, and welcome to the Texas GIS Day 2020, the workshop on social media and data mining. My name is Lei Zou, and currently I'm an assistant professor in the geography department at Texas A&M University. So this year is a little bit different. First, we have the Texas GIS Day instead of like the GIS Day for different universities. And today I also searched on Twitter to see what's going on with the GIS Day, because we're not the only place having the GIS Day event. And I found out even in Texas, there are several GIS days going on. So in today's workshop, we can collect some of this kind of data to see how people talk about GIS Day and then where people are talking about GIS Day. So anyway, let me introduce a little bit about the outline of today's workshop. First, I would like to give an introduction about why social media and data mining is important or interesting, and also provide some background information about how to analyze social media data in terms of the methods, steps, and some general outcomes we can expect from analyzing this kind of spatial data. And second part of today's workshop is some fun Python programming with Google services, with Twitter, to help you first learn how to use geocoding APIs. I think we have another session will be instructed by Dr. Dan Goldberg about his geocoding server. But today we will use the Google one as an example, and later on you can learn, how to leverage the maybe a better resources at the Texas A&M University. We'll also introduce a little bit about how to collect the Twitter data, how to generate the word cloud in a Pythonic way, and how to conduct some sentiment analysis based on the tweet contents we collected from the social media platforms. So let's get started. Why do we need to mine social media data, and why is it important? So many of you are from the GIS or geography background probably know remote sensing very well. So remote sensing is the science of obtaining information about objects or the areas from a distance, and typically from either aircraft or satellites. A remote sensors can collect data by detecting the energy that is reflected from the Earth. So it could be passively or could be actively collecting those kind of energy. And based on the spectral characteristics, as you can see here, whether this is grass or water or soil, we can categorize the land surface into different land cover types, or even specifically land use types by either the developed land, the working areas, the residential areas, or entertainment areas. So that is the concept of remote sensing. But remote sensing has its own disadvantages compared to the advantage of large coverage. You can detect long-term changes, like remote sensing data. You can detect the land cover change in the past 40 years. And it is very fast and near real time for some satellite images, not in a super high spatial resolution. And also you can analyze the geographical phenomena at different spatial, temporal, or spectral scales. But problem or some of the missing information in remote sensing is that we cannot obtain the socioeconomic features. Like when we observe the city of College Station from the satellite images, we cannot observe like what are the people living in here, what are the human dynamics or the mobilities of people in here. And the most important thing is that it is very difficult to obtain a short period real-time information. Like some events happening in just a few minutes or a few hours, those kind of information are very difficult to collect from remote sensing images from satellite images. So we can see remote sensing works pretty good for the physical world. But how about the social world? If we would like to know the mobility, the activities, the networks between people, the connections among different locations or different governments, and later on, if we want to know the emotions, like how people feel about different events or different topics. For example, if we want to know how people feel about the climate change, or whether people believe climate change is happening or not in different locations. In addition to survey, do you have another way to collect this kind of like information about the social world? And the answer is yes, there is actually more data we can collect nowadays. So traditionally, we have remote sensing, we can collect data in the field, or we can distribute some surveys to the people or residents to also collect data for different locations. But nowadays, with the emergent geospatial big data, we can collect data directly from social media, from some transportation applications like Uber or Lyft. Or there are also some volunteered geographic information can be obtained from some online platforms like the OpenStreetMap, the Wikipedia, or from Yelp. So those emergent geospatial big data actually provides us more opportunities to observe the human world, especially the social world, analyze human behaviors in addition to the physical phenomena, and later on, especially in my research, to better understand how people respond and react to the environmental changes. So to conclude, what happens, what is, can be derived from those emergent geospatial data, there is one more concept which is be defined as the social sensing. So this concept was proposed by MIT, researcher from MIT, and later on be applied into the geography world by a professor from Peking University, Dr. Yu Liu. And here is one concept I modified from his definition about what is social sensing. So it is the science of obtaining socioeconomic characteristics about the individuals or the communities from big geospatial data, such as social media data, the mobile sensor data, or crowdsourcing platforms. And in social sensing data, each individual plays the role of a sensor. So you can see everybody, including us, as long as you are using the social media or different web application or cell phone-based applications, you're actually acting as a sensor to collect data about your surrounding world. So this actually provides additional information to the remote sensing data, which is only about the land surfaces. We actually can have the data about the individuals, the communities, the mobilities, and even the psychological conditions. So here are some very interesting and popular applications of social media. For example, you can understand the public awareness of environmental changes. Like this is one study to analyze the public awareness of the air quality and air pollution in China. You can also poll the public attitudes towards different other topics like clear energy in here. So this is one study I was involved in to analyze the public emotions, the public sentiment towards the clear energy. And as you can see, those counties in blue or in green, it means the public sentiment are positive towards the topics either in coal or solar energy tweaks. And those counties in red in here means those counties show a general negative attitude toward the type of energy in here. So in general, based on this study, you can see most areas in the United States more positively have a more positive attitude towards clear energy compared to the traditional energy. And this is a very interesting study from my work, which is to use social media for emergency management. So many of us has experienced the Hurricane Harvey, or at least read some reports and articles about Hurricane Harvey. And you can see many people started to use social media to request rescue during Hurricane Harvey. And since then, social media became gradually became a platform that has been used in emergency management a lot. So in here, we list some examples of the tweets about how people request rescue. They will provide their information, the contact, the people who need rescue, and also their address information. So as geographers or as spatial analysts, when we see those location information, we will be very excited that we can conduct some spatial analysis now. So we can pull out those information from the tweets, get the geographic information, use geocoding services to convert the addresses into the coordinates on a map. And later on, those information can be used by the responding agencies to help those people who are in danger or in need of rescue. So there are many applications of social media data mining in addition to the 3 examples I listed in here. And today I also want to share how you can collect and analyze social media data for your specific research questions. So here's an introduction about what kind of information we can derive from social media. It is a very powerful platform. The data are there are also abundant data on social media, but it doesn't mean social media can do everything or it can monitor anything happening in the real world on social media. It's just, not always true. So for the dimensions of information provided by social media, in general, there are 4 dimensions. The spatial dimension in terms of the geographical distributions of people who are using social media for different purposes. The temporal dimension in terms of like when people are talking about different events or different topics. The network dimension defines the correlation among different social media users. Like you are never alone on social media platforms. You actually have some friends you are following and also follows you. You have some accounts you're really interested in, even though they don't follow you, still follow the updates from those accounts. And also maybe there's some of your friends, some people are really interested in your channel and would like to see your updates. So let's describe the network relationships. It is not only about your social network, and sometimes it's also about your working network or other professional networks as well. And finally, also very important dimension is the content. So when people use social media, usually either post some text, some images, some links to some news reports or to some websites, or sometimes post some sound, these videos, those kind of information. So there are a lot of unstructured or multiple structures of content information provided on social media that can also help us to analyze and also to understand human behaviors. So it seems even though social media is not something can achieve almost everything, but still provided a lot of information. But on the other hand, mining social media is also very challenging. First, it is a very typical big data challenge. If you look at the numbers in here, like Twitter has more than 500 million tweets every day. Facebook has more than 1 billion updates every day. And Instagram or maybe TikTok, many of you are probably huge fans of TikTok. I used TikTok once and then realized if I started to watch TikTok, I would never quit the application. So I just deleted the application from my cell phone. But I know it's super popular, and probably you will have like more than 40 million updates on Instagram or TikTok or any other popular social media platforms. So based on the numbers in here, it is actually a huge data challenge. And especially if you consider the data structure, most of the data structure, they're not in the same or standardized structures. Another thing is that the 2 photos might be very small to see, but the photo in the back is someone says this is the Houston airport being flooded during Hurricane Harvey, and you can see the airplane is floating in the water, in the flooding water. And the picture in front you can see is someone saying that they saw a shark swimming with them when they were driving on the highway during Hurricane Harvey. And unfortunately, or fortunately, both photos are fake news. They're not the real photos. But unfortunate thing is that there's one study published in Science 2 years ago saying that fake news actually can be stay longer on social media and also reach to deeper social networks. So people tend to like sharing fake news more compared to sharing the true news or the correct news. Mostly because most of the fake news kind of like eye-catching and also shocking at the first sight when you see it. So even though when people know they're fake news, they still want to share it, maybe just for fun, or maybe some people would believe those are true. So as you can see, there are some challenges in here, and another thing is about digital divide. So social media users are not evenly distributed by the population. So for different communities or for different social groups, they have their own preferences on which social media platforms that they would like to use. So those are some challenges when you need to deeply mine information from social media and provide some valid knowledge or derive some robust analysis from social media that you need to consider when you do this kind of analysis. So anyway, today we are going to use a simplified framework to analyze the social media data. So we start from data collection, do some parsing and cleaning to collect data or the information we need from the massive social media data. And the third step is geocoding to convert the address information from user profiles into coordinates, save the data in a database, and finally we can do some analysis and visualization. So just before moving forward, I actually put all my information, the Python code and the slides in a shared Google Drive. So let me get a link. So if you're interested in following my workshop, or if you are interested in the slides or materials, I just post the link in the chat box. So you can directly go to the link, download the materials, and try it out. But if you cannot follow me and try the code during the workshop, that's totally fine, because I actually add a lot of comments in my code. So you can actually either after today's workshop, you can still go through the code and see how it works. So let's move on. The journal task in here is that we want to input some keywords in here. For example, where are people talking about the cold weather now? Even though I think this year is pretty warm in Texas, we did experience some cold weather in the past few weeks, but occasionally just 1 or 2 days a week. Usually, I would consider today this year is a warm winter year. So probably we can change the keyword from cold to some other keywords of your interest. But suppose if we want to know where people talk about the cold weather, the input of our code should be just the keyword, the code. And then we would like to have a Python code that can take the input and then create an output of the heat map of the Twitter density, showing where are people talking about cold weather right now. And in Python code, we're going to go through the same 5 steps we just mentioned in our last slide. Data collection, the parsing, geocoding, storage, and finally, the visualization. So there are some requirements, which some of the requirements are very easy to do. For example, like the modules, if you have Python installed on your computer, you should have some built-in modules in here, like the JSON, the system, the time, the URL labs. But if you have never used Twitter or used Python for Twitter data analysis or collection, you probably need to install this package, which is called TwPy. So TwPy is probably one of the most popular packages for Twitter data collection using the Twitter provided API. But TwPy is actually a package which is built upon the Twitter API to help you collect Twitter data more conveniently compared to directly using the Twitter APIs. But in addition to that, you still need to obtain your Twitter API keys and tokens and your Google geocoding API key. And so actually I provided some of the keys and the tokens for, so if you go to my folder and go to the module 2, Twitter streaming, you will see I actually provided 8 pairs of the keys and tokens that you can use. So you can see those are my own keys and tokens. You can directly use it for this workshop. After the workshop, after 2 days, I will update all my keys and tokens. So in case some of you will keep using my tokens and keys, I probably need to pay for it. But for now, you're welcome to try and test it, okay? So I actually provided 8 pairs. You can choose from one of them and test the code I provided in here, just for your information. Before moving forward with the coding part and the fun part, we probably need to introduce a little bit about what is an API, the application programming interface, and how it works. And especially if you look back in here, we need to get the keys and tokens for Twitter and geocoding API. But how exactly it works? Why do we need these keys and tokens? And how do we use it in the code? That's something we need to learn first. So you can consider yourself as a client who is trying to order something in a restaurant. When we order something in a restaurant, the waiter will serve us the API. You do not talk directly to the kitchen, but instead you're talking to the waiter, which is the API. So you need to tell the waiter, the API, what are your requests? So what exactly do you want? You can say, I want some data, and the data need to contain the keyword of GIS day or the keyword of cold weather. Or you can tell him, like, I want to collect the information that has some geographical location embedded, the geotext embedded in the tweet content. And those are some requirements, or you can see some menu you can choose from. And once you make your order, give the order to the API, which is the waiter will take your order to the kitchen, to the applications. The applications will process your orders and get your service or the data you requested and ask the API to return it back to you. So it's kind of like a request and response process. You send the request through the API to the application for either the data or the service. And the application will return your request, the results of your request as a food. You can consider it as either the data or the services, also through the API back to you as the client. So this is kind of like the principle or the concept of API. So it seems to be very simple, right? We just need to talk to the waiter. But in programming or in a way, how can we obtain the access to those API is actually a very simple steps in here. So I made a simple graph in here to help you understand how you can request the keys and tokens for different APIs. And in most of the cases, the way to request the keys and tokens for different APIs are almost the same. So as a developer, a researcher, or just people who are interested in getting some data or service from Twitter or Google, what you need to do is you need to go through to the warehouse and just like when you need to borrow something from your friends. So you can knock the door and your Twitter or Google, your good friends will ask you, howdy, who is it? So you're going to say, hi, my name is Lei, and this is the first step. You need to register a Twitter or Google account. So if you don't have a Twitter or Google account, then it is very unlikely they will provide you the services you're requesting. So once they know, okay, it's my friend Lei, and they will be very warm-hearted and ask you, what can I do for you? So Twitter and Google, they're very generous friends. And so I'm going to say, okay, I need some Twitter data, or I probably need some Google geocoding services. So that's the second step you need to accomplish. You need to create an application in the web page. And in the application, you need to explain what exactly is your request. So you can just simply explain that I want to collect some Twitter data for a course project. I want to employ the Google geocoding services for converting some addresses into coordinates. So once you clearly state your purpose of asking help from Google or Twitter, they will tell you, okay, here's the key. You can come in and start collecting your data or using our services now. So this is the third step. You need to obtain the keys and tokens. As you can see, I just shared with you, the keys and tokens doesn't seem like very reasonable. It doesn't look like a key or doesn't look like a, but it looks exactly like the passcode or password you used a lot when you create an account for any platforms. Okay, so you can consider those are your password or your passcode to access data or service from Twitter and Google warehouse. So once you have the keys and tokens, you're basically all set and ready to do some programming, the fun part. So how to get the API, not from the cartoon way, but from the real world. So you can first go to this website, the developers.google.com. And once you go to the website, you can go to the products, the menu on products on the top left, and go to the Maps platform. And when you click on the Maps and platform, there's one button that says Get Started. So you can say Get Started and choose places and choose, like in here, you can check the places and say Continue. And finally, there's one option to, you can say, I want to have my API key. So once you select the API key, the system will randomly, or not randomly, will automatically generate an API key for your account. So every time when you use the API key to run some geocoding or other Google provided services, it will be accounted under your account. Okay, and for geocoding services specifically, Google provided 2,500 free geocoding services for every account every day. So if you don't have a lot of data to geocode, or maybe your application don't have a lot of users, like you are very confident that your users will not geocode more than 2,500 times a day, you can directly use the free services by Google. But for a lot of applications, especially location-based applications, their number of customers are huge, and it turns out they need to pay Google for those kind of like geocoding services. Now, how does it work for the Google geocoding API? So everybody, I think, is very familiar with the Google Maps. If you want to find out where is Texas A&M University, one of the best universities in the United States, what you are going to do is you will go to the website, www.google.com/maps. And in that maps, you only need to type in the location you are interested in, the Texas A&M University, and what will be returned is a graphical interface showing the map, the location of the your point of interest, and also some additional information providing like the images, some texture addresses in here. Yeah, that's a nice name, I guess. So another way is that in addition to directly search for Texas A&M University on the Google Maps, you can also directly get the coordinates. Because when we do spatial analysis or when we do some spatial visualizations, what we really care is the coordinates, right? Once we have the coordinates, we can import the coordinate as a point in different spatial analysis software or in programming interface or in different web applications that can really make sense of the point. So instead of using the Google Maps the website in here, you can use the Google Maps API to get the location information about the same address in here. So if I want to know the coordinates of Texas A&M University, instead of going to the google.com/maps, I can go to this website. As long as you have your key in here, you can type in your key and also provide your addresses in here. So if I go to my website, let me see. So this is what you will see if you search for Texas A&M University. And this is what you will see if you use the Google geocoding API. So as you can see, I'm not sure if you can see it. It's very small in here. So this is the template of using Google geocoding API. You have the Google APIs.com, which is the server name. You have the folders from maps to API to geocode, and we would like to have the data returned in JSON format. And everything after the question mark in here is the parameters of using this API. So there are only two parameters in here. The first one is the key. So key equal to the key of my API key, and the address equal to Texas A&M University. And as you all know, we cannot have space in a web address, so or in a web link, the URL. So the space will be translated into %20 in here. So Texas A&M University, the address will be translated to Texas %20 A&M %20 University. So this is a link how we can get the JSON geocoding results by searching Texas A&M University. And the information provided in here is actually more than you can imagine or expected. So there are some address components, the street number, name, and most importantly, we have the coordinates. So if you go to the geometry location, you have the latitude and longitude. And you can see the status in here is called OK. So which means every time when you use the Google API, if the status says OK, it means in Google server, they found address that matches your inquiry. If the status is not OK, like 0 or something here, it means they could not find a matching record with the address you input into the search API. So this is a Google geocoding API, and we're going to use it in the code. So here's the code you can use, the module 1 geocoding example.py. So let me show my code in here. If I go to the first one, module 1 geocoding, then as we can see, we have the we need to import the URL lab, the parse and request in JSON. So I'm going to skip all the explanation about the code. The only thing I want to remind you is that when you run the code by yourself, you need to change it to your own Google API key, because I probably will refresh my API key and regenerate a new one, so that if otherwise if everybody's using my API key, then probably tomorrow I will receive $1,000 bill from Google, which is something I do not want to see. Okay, so you can change it to your own Google API key, and the other thing you need to change is the address information. So all the thing here is trying to use in a coding way to do what we just did in the web browser. So we'll open the web browser for you to find the address, formatted address by linking your Google API key and address with the Google API geocoding API template, and finally return the results and print it out on screen. So let's try the Texas A&M University and see how it works. So if I run my code, what will be returning here is, first I print out the JSON format results, so which is exactly what we see from the web page. And secondly, since this is a JSON format, so we can use JSON to read the information we're interested in. So the information we're interested in is the results 0 and the geometry, location, and because we want to know latitude and longitude. So if you look at the final printed out results, the latitude, longitude, and address. So this is exactly what we need to do, and this is what we will need to use for the second coding part of collecting the social media data. So if you have time, and also if you have the code downloaded on your computer, feel free to play with it. And I'm going to continue about how to directly collect the Twitter data in here. So for Twitter data collection, it is more complicated, because for Twitter data, the Twitter API, they actually need to go through a review of your application and determine whether they will provide you a developer account or not. So I put very detailed instructions in here. You can go through my instruction, like always remember where is the click me. You see, every time when I highlight something, click me, trust me, click it. Otherwise, you will not find out how to obtain your keys and tokens. And in here, click me, put the information needed in here. So go through all this website, go through all these steps, and then what you will get is the keys and tokens in here. So if I go back to my coding interface, you can open any programming editors, any text editors to modify your code. I'm just using Sublime, but right now I think VS Code is more popular. So if you're interested, you can also download the VS Code and start to modify your code. So anyway, as you can see, this is the keys and tokens. There are actually four values in here, mostly something randomly generated by the characters, the letters and numbers. So this is something belongs to you, and you should never share it with others. So, okay, so I do share it with you guys, but don't use it for any bad purposes. Now, this is the second Python code we need to use. So if you go to the module 2 Twitter streaming, and there is a module 2 Twitter streaming underscore example. So you don't need to worry too much about the coding here. Basically, we leverage the TweetPy package to directly connect to the Twitter API with your own keys and tokens. And finally, we use the Google geocoding API to convert and address information into coordinates so that we can create some visualizations. So you don't need to make any changes to the code except for one part in here, the keywords. So in here, I just put GIS day and the GIS day. So some people just say GIS space day, or some people just directly say GIS day as the keyword. So you can put any keywords you're interested in here. You can also put up to 400 keywords. separated by the comma sign. Okay, so you can continue adding more keywords like TxGIS Day in here to collect any tweets related to GIS Day or any tweets related to the topics of your interest. But I'm going to delete this one because I just want to know in a world where people talk about GIS Day, not only in the United States. And for the rest of the code, right now, the huge part in the define on data is commented. So as you can see, this means comment. And the reason why is that I want to first show you how one tweet collected from the Twitter API looks like. And later on, we can convert all the tweets following the step in here, the geocoding, the step 4, create a CSV file to save the data. And finally, visualization will be in the third module. So let's take a look at how the data will look like if we collect one tweet containing the keyword GIS Day. So let me run this code and see how it works. So every time when you want to customize your code, you only need to, based on my template in here, you only need to make modifications in the on data functions in here. Okay, so right now I guess nobody's tweeting about GIS Day, but if you have your Twitter at your hand, you can tweet one tweet about, you can post one tweet about GIS Day, and probably your tweet will be show up in here. Well, finally we have one tweet. So let me cancel my build and start to. Oh, that's a very good suggestion. So we can definitely use the hashtag in here, TxGIS Day. So let me run the code later with the TxGIS Day, but let me put it in here as a keyword that we need to collect. Okay, so as you can see, there are actually a lot of information provided by Twitter. So first, the contributor right now is none, but it has a time, and the time system in Twitter is a little bit different from the time system in the central standard time we have right now in Texas. So you can see the text is GIS Day. If you go down to here, the text in here, there's a hashtag called GIS Day, and it says GIS Day is this week. Super excited to be speaking at an event, virtually of course, or of course. I guess it's of course, but I'm not sure. Maybe it's a typo. But anyway, as you can see, you actually have a lot of information about first who the person is. So if I scroll down in here, you should have the information about the user. So the screen name is Randy Bouncer Jr. So you probably can find out who is he or she and probably more information about him or her. But most important thing we need is the location in here. So based on location, it says Yakima, Washington, I guess. So you basically can use this location with the geocoding API we just provided to find out exactly where this person is located, not in a super high spatial resolution, but in general analysis or in a not very high spatial analysis, spatial resolution analysis, it should be enough for us to accomplish. Okay, so let me uncomment all my code in here. If you look at these two lines in here, if listener.count greater than or equal to 25, I'm going to raise the system exit of this code. So it means once I collect more than 25 tweets, I'm going to exit my code. And we're going to create a visualization based on the 25 collected code. So let me uncomment everything, and probably it will take a long time because first I'm going to have a sleep every time when I use a Google API. And secondly, probably it will take some time to collect enough tweets, more than 25 tweets, containing one of the 3 keywords in here. So let me save my code and start it to build again. So every time we need to collect one tweet, it will be printed out. And also, as you can see, we're going to get the location. And I'm not sure how long it will take, but let's wait and see how it works. So in general, if you look at the code in here, we will not write too many informations into our twitter.database.csv. We're going to have the latitude and longitude, and that will be all, okay? So if you look at it in here, I've already tested my code and started to collect the data before the workshop starts. So I already have more than 30 records recorded in here. So as you can see, we probably only receive a few tweets in here. And it will probably take a little bit longer time in here. So for example, this is one in New Jersey. Don't miss Amanda, Paula, and Peter online at the Relays Free GIS Day this weekend, this Wednesday. So there are a lot of things going on about GIS Day, but still, compared to public discussion about either sports or other things, maybe the number of tweets is still smaller compared to other topics. So I'm going to stop my coding here, cancel my build. Because I already have more than 30 records in here, which is enough for the visualization. So once you have the data collected in here, you can copy your TwitDB CSV into the third module. And for example, if I want to copy and paste, I go to my second module. This is data we just collected in here. Go back to the third module. I'm going to paste it and replace it. So next thing you need to do is you can directly go to the third module and start to run the visualization. So you can either just run visualization.py to show the addresses, and it will pump up into, it will open your web browser automatically and shows where the location is. So most of the people talking about GIS Day in our database are in the United States, but you can also see one in Argentina and some in the UK and Germany. And then another thing you can do is that you can use the heatmap.py. So heatmap.py will create a heat map and a dynamic heat map, which is a Google services based on the point data you just collected. So it will open your web browser again and shows up another new map showing the heat map of places where people are talking about GIS Day. And you can keep zooming and zoom out, and the heat map will update it automatically based on the scale of your data, or based on the scale of your map view in here. So it seems to be very interesting and I guess very useful if you just want to collect some Twitter data and visualize it in a map. Okay, so let me go back to my slide because I think we are almost running out of time. But if you are interested in learning the details of the code, you can follow the instructions in here. I have a step-by-step coding explanation in my slides, also available in the Google Drive. So you can learn why we need to add different sections in the code and what are the expected outcomes or change of the results by adding or removing different sections in the code. Now, once we have the Twitter data, we can also do some natural language processing to understand what are the words people use when they talk about the topics or the events you're interested in. So, so definitely there are many ways to generate a word cloud, but we can also generate a word cloud in a Pythonic way. The module we need to use is word cloud and matplotlib. If you don't have it, you need to install it for your Python, or just give you a little bit more information. So if you're using a Mac, you can actually find which Python version you are using. So if I have Python 3.6, 3.7, 3.8. So if I want to know where is my Python 3.8, you can find out the directions in here. Okay, so if I want to install, for example, pip install something, like you need to install word cloud, you can say pip install or pip3 install the word cloud, something like this. But since I have already installed it, so I don't need to do it again. Okay, so sometimes if you have multiple Python versions on your computer, it might cause some confusion. So it's very important to manage your different versions of Python. Since I'm running out of time, I'm going to run my code, show you how it works, and we're going to conclude our today's workshop. So this is, if you want to generate a word cloud based on the Python and the Twitter data, which we have an example is the Twitter related to Hurricane Sandy in 2012. You can either use the first example by uncomment everything And also remember to comment everything in the second example to make sure you will not generate multiple results from this code. Okay, so we're going to generate a word cloud based on the text in here. And as you can see, those are just the pure tweet contents. So you can directly run the code. And if you go back to the main interface, what you will see is, sorry guys for keep you staying here for a little bit longer. I'll finish in 2 minutes, I promise. Okay, so this is a word cloud generated based on the tweet contents. Okay, and sometimes if you want to generate a word cloud, not in a square shape, you want to generate a word cloud based on your input images. Like you want to generate a round word cloud or just a word cloud of any shape of your interest. You can actually input an image in here. So if I want to generate a word cloud, which is the shape of the Earth and also colored by the color on the earth.jpg, the image in here. What I can do is I can input this image, and the word cloud will generate it based on the shape and the color of this image. So most of the tweets are retweet. So as you can see, RT is probably the most frequent word. But you can also say like Sandy, the Hurricane Sandy, and if I remember correctly, somehow Justin Bieber is also one hot keyword related to the Hurricane Sandy, and I still don't know why it happens. So finally, for the sentiment analysis, just one simple code in here. You need to install the Vader sentiment package, and once you install the Vader sentiment, you can try it out. If you like today's workshop, you can see I like this workshop, and supposedly the sentiment analysis tool will return a positive score. And if you don't like it, unfortunately, don't tell me, tell the code, and the code will tell you, okay, this is a negative sentence. So let us run it, and you will see the results in here. For the first sentence, welcome to social media data mining workshop. It's pretty positive, as you can see. The compound score is 0.45. So the overall score will be -1 to 1. So 0.45 is positive, but not extremely positive. For I like this workshop, the score is 0.67. It means pretty positive. If you don't like it, it will show a -0.6. Okay, so that's all I have for today, and hopefully you learned something useful, interesting. All the codes are available, so have fun playing with the code. This is a quick summary. Hope everybody will do something special with social media or other geospatial big data. Thanks again for your time, and hope you will enjoy the rest of the GIS day. Oh yeah, some very interesting questions. So I will stay here to answer some questions. The first one is that you're saying, is the presentation instruction available? Yes, let me send the link again. So here's a link to the Google Drive. I put everything on this Google Drive. So if you're interested in the slide, or if you're interested in any of the code, feel free to use it. Okay. And secondly, and also thank you very much for your encouraging words. Secondly, the question is about, is it possible to change sentiment analysis language? So sentiment analysis is actually a very difficult task. And this tool, this Vader sentiment analysis tool, was developed in 2014 and only work for English. But fortunately, there are also some tools can automatically translate different languages into English. So my recommendation is that you can translate your non-English sentences or text into English first, and then later on to run the sentiment analysis. There are definitely some sentiment analysis tools available for different languages, because, for example, I know there's one tool for Chinese, and there's some tools for other languages. But the challenge is that if you are using different tools to evaluate the sentiment, either for Spanish, for Chinese, for Japanese, for English, it's hard to compare the sentiment scores evaluated by different tools. So overall, my recommendation is translate it first and then evaluate the sentiment secondly. So hopefully I answered all your questions, and but otherwise I have my email address in here. Anyone interested in talking to me or have any questions about the workshop, feel free to email me anytime.